Thank you for watching my video. My name is Astrid Krasniqi. I'm authorized CCNA and CCNP Cisco trainer. Now we are covering section 10.2, well-known application layer protocols and services. This is a part of the chapter 10 application layer, CCNA semester 1, introduction to networks. In this lesson there is two demonstrations. Number one is configuring DHCP services, and afterwards we configure DNS services as well.
Hypertext transfer protocol and hypertext markup language, for example HTTP. HTTP, if you give it in the address bar, you write http://www.cisco.com/index.html. Now HTML is the language for this website, and HTTP is a protocol for www. So the browser will look and say, okay, the HTTP part of it is a protocol or scheme that we are using. www.cisco.com is the server's name. Okay, so you're using HTTP and you are accessing cisco.com, and you're asking for a specific file they're requesting, which is index. Browser checks with the name server to convert. So first, before the browser can actually go and get the www.cisco.com, it needs to find out the numeric address. How it does that? It asks the DNS. So using HTTP protocol, requirement set a GET request to the server and ask for the file index.html. Server sends the HTML code for this website or web page. Three common messages types are GET, POST, and PUT in HTTP. SMTP, POP, and IMAP. Email is a store and forward method of sending, storing, and retrieving electronic messages across a network. Email messages are stored in database on a mail server. ISP often maintain mail servers that support many different customer accounts. Email clients communicate with the mail server to send and receive the emails. Mail server communicate with other mail server to transport messages from one domain to another. An email client does not communicate directly with another email client when sending email. Instead, both clients rely to the server to transport the messages. This is true even if both users are in the same domain. The application layer process that sends the email uses SMTP, and the client retrieves email, however, using one of the two application layer protocols, POP or IMAP. So two clients, they don't communicate with each other when they send an email. A client will send an email to the server using SMTP. Now the server will, it's called mail transfer agent. The server is going to send the email to the other server, to the mail delivery agent. And then the client will retrieve that email from mail delivery agent through using POP3 or IMAP. So you can see the two clients that never talk to each other. One, you are sending to the server, and the other client has to go and receive it from the server. So simple mail transfer protocol, transfer mail reliably and efficiently. The client SMTP process connects with the server SMTP process on a well-known port 25. The destination email server might not be online or might be busy when email message is sent. Therefore, SMTP spools the messages to be sent at a later time. So when you send them the messages, the mail transfer agent will send them to the mail delivery agent, and mail delivery agent is going to hang on to them until this client receives them or requests them. Post Office Protocol, POP, enables the workstation to retrieve emails from a mail server. When POP, mail is downloaded from the server to the client and then deleted on the server. So email, if using POP3 for example, is downloaded from the server to the client, and the server will delete the email. And he's using port 1110, TCP port 1110 to receive that email. Domain name services. In a data network, devices are labeled with numeric IP addresses to send and receive data over networks. Most people cannot remember these numeric addresses. Domain names were created to convert the numeric address into a simple, recognizable name. On the internet, these domain names, such as HTTP, www.cisco.com, are much easier for people to remember than 198.133.219.25, which is the actual numeric address for the server, for the Cisco server. If Cisco decides to change the numeric address of the Cisco.com, It is transparent to the user because the domain name remains the same. The domain name system, DNS, was created for the domain's name to address resolution for these networks. The DNS uses a distributed set of servers to resolve the names associated with these number addresses. So client, if a user wants to access www.cisco.com, the client will send a request to the DNS server. Will say, okay, I need that to be resolved for me. And the DNS server is going to resolve that to an IP address for the client. The message format, the DNS server stores different types of resources record used to resolve names. This is the message format. So we have a header, we have a question, the question for the name server. Then we have the answer, resource record answering the question, and then authority, resource record pointing towards an authority, or additional resource record holding additional information. These records contain the name, addresses, and type of records. Some of the records that we have are A, an end device address. So A record, for example, would be PC1 is on IP address 192.168.1.10. Or we have a new one, which is quad A, that's for IPv6 addresses. An NS name server, an authoritative name server. CNAME, or the canonical name for an alias, used when multiple servers have the single network address, but each server has its own entry in DNS. MX, mail exchange record, maps a domain name for a list of email exchange servers. If it's unable to resolve the name using its stored records, it will contact other servers. So for example, if you ask your DNS server to resolve a name, and then that DNS server has never heard that name, it's going to ask its own DNS servers. It's going to keep going. It could even go to the root of the servers and ask them. Server temporarily stores the numbered addresses that matches the name in the cache memory. So if you match a name, if you resolve a name to an IP address, you're going to keep that on the cache. You can see that if you open the command prompt and you type ipconfig/display DNS, and it will display all cached resolved names to an IP addresses. DNS hierarchy. The different top-level domain represent either the type of the organization or the country of the origin. Example of the top-level domains are .au for Australia, .com, a business or industry, or .org, a non-profit organization. We have .co.uk, what else? .mil for military, and so on. So all these are top-level domains. After the top-level domains are second-level domains names, and below them are other lower-level domains. So DNS relies on the hierarchy of decentralized servers to store and maintain those resource records. The resource records list the domain names that the server can resolve and alternative servers that can also process requests. If a given server has a resource records that correspond to its level in the domain hierarchy, it is said to be authoritative for those records. NS lookup. Computer's operating system also have a utility called NS lookup that allows the user to manually query the name servers to resolve to given hostname. This utility can also be used for troubleshooting name resolution issues and to verify the current status of the name server. The name of the host or domain can be entered at the next NS lookup prompt. Then we have a dynamic host configuration protocol. The dynamic host configuration protocol service enables the device on the network to obtain IP address and other information from DHCP server. This server automates the assignments of IP addresses, subnet mask, gateways, and other IP networking parameters. This is referred to as dynamic addressing. The alternative to dynamic addressing is static addressing. When using static addressing, the network administrator manually enters IP addresses, information on the network host. DHCP distributed addresses are not permanently assigned to host, but are only leased for a period of time. If the host is powered down or taken off the network, the address is returned to the pool for reuse. This is especially helpful with mobile users that come and go on the network. So a client machine will send when it needs an IP address dynamically, will send a broadcast message that says DHCP discover. It's trying to discover a DHCP server. Then the DHCP server will respond by saying a DHCP offer, given an IP address on offer with an IP address, subnet mask, gateway. The client will send a DHCP request saying yes, I like those addresses, information that you gave me. And then the server will send a DHCP ACK, which it will acknowledge, and it will remove that IP address from the pool. So this process is called the DORA process. We have a discovery message, then an offer from the server, then a request from the client, and then acknowledgement from the server again. So DORA process. File transfer protocol. The file transfer protocol, FTP, is another commonly used application layer protocol. FTP was developed to allow for data to transfer between a client and a server. An FTP client is an application that runs on the computer that is used to push and pull data from the server running an FTP daemon. FTP requires two connections between the client and the server, one for the commands and replies, another for the actual file transfer. So number one, control connection. The client establishes the first connection to the server for control traffic. Consists of a client commands and server replies. The second connection is data connection. The client establishes the second connection to the server for the actual data transfer. This connection is created every time there is a data to be transferred. Then we have a server message block. Server message block, SMB, is a client-server file sharing protocol developed by IBM in the late 1980s to describe the structure of a shared network resources such as directories, files, printers, and serial ports. It is a request-response protocol. With the introduction of the Windows 2000 software series, Microsoft changed the underlying structure for using SMB. So every time you open a file and you see a share or something on your Windows computers, that's an SMB protocol. The Linux and Unix operating system also provide a method of sharing resources with Microsoft Network using a version of SMB called Samba. The Apple Macintosh operating system also supports resources sharing using SMB protocol. Okay, now we'll see a demonstration on observing a DHCP communication. For this, I'm going to use GNS 3. So I have a router 1 here. I'm going to configure this router with IP address. We're going to do 192.168.11.1, and we're going to configure for DHCP. So this is going to be the DHCP server, and network is going to be 192.168.11.0 /24. DNS server, I'm going to put DNS server. Let's just use another one, something else. We're going to make up. We don't have a DNS server on this network, so 192.168.11.5. We're going to put default gateway. So default gateway. Let's use 192.168.11.1, which is going to be this router. And we're going to put the domain name. So domain name cisco.local. So okay, so this is what we're going to do. We're going to have a DHCP server. So network is going to be 192.168.11.0, that network. DNS server is going to be 192.168.11.5. Default gateway is going to be 192.168.11.1, which is going to be this interface of this router. And the domain name is going to be cisco.local. Let's continue with that. We're going to give it a lease. So these addresses, we're going to leave them for 4 days only. And what else can we do there? That's about it. We're going to exclude some IP addresses. So the excluded IP addresses are going to be 192.168.11.1, and we're going to exclude addresses up to 192.168.11.10. So first one should be 11. Okay, this is what we're going to configure. Router 1. So open the secure CRT, and just going to see if there's any configuration on this router. So show run. There shouldn't be any configuration. Okay, there's nothing. There's no configuration whatsoever. So I'm going to open a new notepad, and on that configuration I'm going to do a basic startup configuration. So enable configure terminal, hostname, it's going to be R1, enable secret class, service, password encryption, and no IP domain lookup. And what else can we do here? A banner, MOTD, authorized users only. If you don't know what these commands are, what do they do, you can check chapter 2 and it will explain them in detail. I'm going to configure the console 0, password Cisco, login, login SYN, and exec timeout 00, and line VTY024, password Cisco, login. Okay, so I'm going to highlight all of this and copy it to my router. So highlight all of it, right click, select copy. Okay, excellent. So this is your basic startup configuration, yeah? So we need to do some other configurations. So first we need to enable the interface on the router. So interface FA00, that's the interface that's connecting with the PC. So FA0/0. Give an IP address, so IP address 192.168.11.1, and subnet is going to be /24. Let me just increase this so we can see it in one line. Okay, and we're going to do no shutdown. Down. Right, so we're going to copy this again, right click, copy, go to the router, just right click. No control V or anything, just right click. So IP address 192.168.11.1, and I can see the status and the protocol's gone up. So I can go end and then show IP interface brief, or I can just say do show IP interface brief, and I can see the interface FA00 is up. So the next thing I'm going to do is I'm going to go to create a DHCP. So it will say IP DHCP pool Cisco. So I'm just going to call this as a Cisco or local LAN or whatever. We can call it LAN, our LAN. And what network is going to be for this LAN? So network is going to be 192.168.11.0, and the subnet is going to be /24. What is a DNS server? So DNS server is going to be 192.168.11.5, which is, I'm just going to make it up, that default router. Now that's the default gateway, yeah, but in here they don't call it default gateway, as I've been teaching you. When you configure the DHCP, it's called default router, which is 192.168.11.1. Domain name cisco.local, and lease, how many days? No, 0 days, 4 hours, and 0 minutes, right? And then you can have other options, like for example option 150. If you configure in voice over IP, then you will have option 150 and the IP address of whoever is giving the voice information or configuration. We don't have it here, but just let's create it for just example's sake. 192.168.11.1, and that's about it. We type exit here, and we're gonna exclude. So you need to exclude the addresses that you have configured statically from giving them dynamically as well. So let's just imagine that we have a server 192.168.11.2, printer maybe .3, something else, file server .4, we have a DNS there .5. Let's just exclude first 10 IP addresses. So IP DHCP excluded addresses, say 192.168.11.1, and we're going to exclude up to, so that's the smallest number, and up to 192.168.11.10, right? So the first IP address that we should get, the PC should get, is .11, right? And I'm going to copy this to my router. Okay, excellent. Now I'm going to go to the PC. In my network I have a PCA here, is going to be configured with to get an IP address from this router. So I'll go to using this VMware now. I have a VMware PC. So first thing I'm going to go open the command prompt cmd, and I'll type ipconfig/all. Now this is going to tell me a few things here. First, it's going to tell me that this computer is not DHCP enabled, right? So it says no there, and it's got no DHCP IP address, but it's got one address that is duplicate. IPv4 addresses cannot be duplicate, so I'll configure that .12, not duplicate, not allowed. Right, so let's go and change that IP address. So we're just going to go and change. So open start, control panel, network and internet, network and sharing center, local area connection, and go to properties and just give an IP address, say 5. Oh no, let's take 8, something not used, 8, close. So if I run the ipconfig again, so let me just go through ipconfig. Now I can see the IP address is 192.168.11.8. See if I can ping my router 192.168.168.11.1, and I got a reply from my router. So it's great. I got a connection with my router. So if I set this PC to get the IP address dynamically, not statically, it should get an address from the DHCP server, which is the router. So TCP IPv4 properties, obtain an IP address automatically, right? So okay, close this, and go to the command prompt and say ipconfig now. And yes, it's a bit different now, yeah. So look, before we didn't have a gateway. At least we didn't have a gateway here. There is no domain name or anything. Now we got the new ones, so you can see you have a DNS suffix, domain name, default gateway, right? So there's quite a few information. So if we say ipconfig/all, if I scroll up, I can see that the DNS Cisco.local I'm using. I can see the MAC addresses, physical addresses here. I can see that it's DHCP enabled. I got address from IPv4 address 192.168.11.11 because we have actually reserved from 1 to 10. So 11 is great. That's the one I was expecting. And you can see that it's been obtained for 4 days only, right? So from the Friday, September 18th to Friday, September 18th, yeah, 1 day, sorry, and it's for 4 hours. So from 11 a.m. to 3 p.m. is 4 hours. I got default gateway 192.168.11.1. The DHCP server is the same as the gateway, and the DNS server, like we configured, is 192.168.11.5. All the information that we have given on our notepad here. If you look, all this information. .5. So let's go here. Can't see them together. Okay. Anyway, what we want to see is we want to see actually this happening on the Wireshark. So what we're gonna do is we're gonna delete this configuration that we have. So ipconfig/release. Right, so there's no configuration. So now when I do ipconfig, there's nothing there. Okay, so I'm gonna open Wireshark. Let's just configure a static IP address here for a second. So there's no messages appear, some messages that we don't want to see. That address that we were using, 192.168.11.9, and that's it. No gateway, nothing. Just click OK and close. Right, so if I do ipconfig now here, I should see my address that I given, yeah, 192.168.11.9. Okay, so what I'm going to do is go back to the GNS and right click on the cable here and stop previous captures that we have and start a new capture. So right click on the cable, start the capture. This is going to ask me, do I want to capture switch SW1 port, this port here, or do I want to capture the R1 ports? Yes, I do. R1 port FA00. Click OK. This will open the Wireshark. as you can see, there are already some messages that start coming up. Right. So what we want to see is we want to see the DHCP messages. Okay, so I'm going to open again the client machine and go to and set this interface to get the IP address dynamically. So right click or select TCP IPv4, click on properties and obtain an IP address automatically, obtain DNS server addresses automatically. When I click OK here, I should start seeing something on the Wireshark. So click close. Yep. So you can see right away I got some DHCP, but it's hard to see it. So I click stop this and I'm gonna filter. So I click filter. Now what I want to filter with is I want to filter with DHCP. So I just want to see the DHCP services. So I click create a new one. So create new. So click on the expression. And what do we want to see? The Wireshark sees DHCP as a boot P, yeah? So find the boot P. So the boot P and DHCP. Okay, that's the one. Boot P and DHCP. So click OK. I just want to say DHCP filter, and click apply. Okay, get rid of this expression. We want to select boot P again. There we go. And click OK. And apply. And OK. Now we can see the messages, the DHCP messages. We have a DHCP discover message coming from source nowhere, and its destination is broadcast. Then we have an offer that's coming from our router 192.168.11.1, and the source, the destination is again a broadcast. We have a request message from nothing to broadcast, and we have acknowledgement from 192.168.11.1. It says into the broadcast, and then inform message from our client that's got the IP address .11.11 to the broadcast, and then acknowledgement again from the server. So let's open this discover message and see what's inside. So if I double click that discover message and just maximize it so we can all see it, we have Ethernet layer 2 information. So the source is the IP address of this VMware machine, and the destination is a broadcast. And internet or IP layer is version 4. The source is all zeros, so 0000. Destination is another broadcast message. And the user datagram protocol, which means UDP, yeah, UDP message. Source port is 68, destination port is 67. So source port 68, destination port 67, UDP, right? And bootstrap protocol. Bootstrap protocol is, this is what DHCP is known as. Bootstrap is a predecessor from the DHCP. So I'll close this and now get the offer from the DHCP server. Again, let me just fix it here so we can see it. Okay, again, this message is going to broadcast. It's coming from the MAC address of the server. And the protocol again is from the IP address of the server, and destination is a broadcast message. And UDP port 67, destination is port 68, always on DHCP. And then bootstrap protocol offer. This is the offer. The offer is the IP address, your client IP address. I'm offering 192.168.11.11. Nothing for next IP address or for relay agent. This is a DHCP type, which is offer. Okay, close this message. And request is a message that's coming next from the client. Says, okay, well, I got the offer. Please, can I have it? Can I have that IP address? So again, port 68 to port 67. And source is nothing. The destination is all broadcast. And bootstrap protocol. Now we got the, again, this is the request saying, yes, I like that IP address. And the last message comes from acknowledgement, which is from the server. So we have a discover from the PC to the server, from the server to broadcast, PC to broadcast, I should say. And the offer is from server to the broadcast. And the request again is from the PC to the broadcast, acknowledgement from the server to the PC. So if I open the acknowledgement and maximize it so we can see it, again these are the same, this hasn't changed. So source, destination again is the broadcast, UDP protocol 67 to 68, Bootstrap protocol. The offer is again the acknowledgement now that yep, so you've got this address, your IP address is 192.168.11.11. Options 53, message type is acknowledgement. DHCP, for example, let's see this lease time. Lease time is 4 hours or 14,400 seconds. What else can we see here? Renewal time, when you need to renew it every 2 hours. So when it's half time of your lease, you need to ask again for the renewal. Subnet mask, what we have is your 255.255.255.0. It's a subnet mask. Domain name server is this address 192.168.11.5. Your default router is 192.168.11.1. Everything is an acknowledgement. And domain name cisco.local. And there's any other options? No, nothing. Option N255. I don't see here the option 150. I thought we configured that, but I don't see it in here. Okay, that's it. So again, if the other protocol, other messages are inform again and the acknowledgement again. So in this video, you saw exactly how everything is happening, how the machine is getting an IP address from the DHCP server by sending a discover message. The server is sending an offer message. The client is sending a request. Yes, I like that IP address. And the server is sending an acknowledgement saying, yep, here you go, you got it. Right. What we can do is we can go through it again. We can like request another message. So for example, let's just change something. Yeah, let's just go to the server and say go to IP but let's exclude some of the addresses. Yeah, so let's exclude up to, I don't know, 50, right? So we're gonna go IP DHCP excluded addresses 192.168.11.1 and 50, up to 50, right? Now, so I'm expecting my PC to get the next IP address that I'll get to the PC is to be 51. So I'm gonna release this IP addresses, and we can do that by typing ipconfig release, and then I'm gonna renew ipconfig renew, right? So the next address I should get is 192.168.11.51. Let's see that now. Okay, we got it. It did take a little time, more than usual, but more than what I would expect anyway. So yes, the IP address is 192.168.11.51. Same subnet mask, same every other information. Okay, just to recap, what I did on the Wireshark is I started capturing. So start the capture, and then as I was capturing, now okay, I need to close this and start a new capture. So stop this capture and start a new capture. Start a new capture. Yes, on the router. Click OK. Now once Wireshark starts, all the messages they're gonna continue is gonna start. So we got some ARP messages here. There you can see who has this IP address. Anyway, what I'm gonna do again, and I'm gonna go to the PC. I'm gonna release and renew the IP address. So release, get rid of that IP address, and renew it again. Right? Now again, I should see some of the messages, some of the DHCP messages coming, but they're all mixed up. So I need to do some filter. Yep, I got the same IP address, which is good. Right. So now I'm going to go to the Wireshark, because there's a lot of messages here. It's hard to find that. Okay, I got acknowledgement there, I got inform there, I got DHCP solicited message there, version 6. Okay, so I can stop this, right? And I'm going to do a filter. So a filter, open the filter. Now the filter that I want usually is not here, right? So this one I recreated. Let's just get rid of that. Let's create a new one. So expression, go to expression. Right, so here we can create a filter by lots of protocols here. Some good protocols like 802.11, right? Some other protocols, but the DHCP is under boot P, right? So I gotta find the boot P, boot P DHCP, bootstrap protocol. So click OK, and then you give it a name. So be a DHCP filter 2, for example, just so it doesn't clash with the other one. Okay, boot P twice, it's gonna give us error. When it's green, means everything is good. Click OK. Now you can see, first you can see the release. I did the release from 192.168.11.51, and then again I went through the discovery, offer, request, acknowledgement, and informed from 51 to the broadcast that I got that IP address, and then last one is acknowledgement. Right. So on this in this demonstration, you saw the observing the DHCP communication. The next demonstration, I'll show you observing a DNS resolution. So again, for this demonstration, I will show you on the same configuration that we had. I'm gonna see that if I find any of the DNS, for example, messages. Right. The first thing I'm gonna do is I'm gonna actually go and change that DNS that we configured. See, configure the DNS something else. Let me just give it to the router. Actually, that's gonna be the DNS, right? So 192.168.11.1. So I'm gonna get rid of this. It said 50 here. Highlight all of this again. Control, right click, copy, and open the secure CRT and paste it there. Just right click and paste it. So now the DNS server is 192.168.11.1. Let me just go into the PC and confirm that. So if I say IP config all, right, my DNS server is 11.5 still. So what I'm gonna do is I can wait here 4 hours, 2 hours to renew it, or I can just quickly say IP config release, and then IP config renew. Once it renews, it should renew my DNS server as well, the IP address of that. So IP config all, and you can see the DNS server has been updated to what we want, 11.1. Pause. Okay, so now what I'm gonna do is I'm gonna open a browser. So just open one of the browsers, and yeah, okay. So it's gonna ask the DNS for this address. So go Microsoft. So if I open Wireshark here, yeah. So right click again, start the capture. Yes, I want to capture the R1 port, pass Ethernet 00. Okay, some of the captures, they're already going to start going. So what I want is, yeah, we can see here the browser. So let's just go to the PC again, and ask me later here, and let's search for www.google.com. right? So if you look here, I already got some of the messages, right, from the DNS messages, right? Again, what I want to do is I want to filter these so I can see only the DNS messages. So I'll go to the filter, and I'm going to create a new one. So this is going to be a DNS filter, and go to expression, and here I want to choose the DNS. So go to D. Okay, there we go. Click OK and apply. Now I got a standard query from the PC to the router. That's the DNS name, DNS server. So if I open that and just fit on the screen properly, right? So here we have an internet protocol. That's a header. So version 4. The header length is 20 bytes. There's no quality service anything in here. Total length is 71 bytes. Again, the source is 51. The destination is .1. Protocol is UDP. right? So UDP protocol. Again, in here when we see like for DNS is UDP, the source port is 63,182, which means it's randomly private port, and destination port is 53. So DNS uses 53. Domain name system, this is a query inside the domain. So we have a question, which is 1, answers there's nothing, and the query is the IPv6, this address, Microsoft.com. So type A, he's asking for IPv4 type of IP address. Okay, so if I close this DNS, and then we're gonna get another one. Again, this is DNS query here. Again, we are using the name that we put there, www.google.com. And again, we are using for type A, we want to resolve this to an IP address rather than IPv6 address. It will be quad A for IPv6 address. Again, it's a question, standard query, nothing fancy about that. All these messages are going to be similar to that, what we captured earlier. So here again is asking for different type. As soon as you open some kind of browser, it's looking for so many other stuff as well. Right, so what I'm going to do is I'm going to close this Wireshark. So close the Wireshark. Yep, I don't want to save anything. And go to the DNS and right click here and say stop capture. Okay, now next one I want to do is I want to actually enable the web services on this router, on router 1. So if I go to secure CRT and say IP HTTP server, right, and user, just create a local database, username, say admin, yeah, it's not gonna tab for that, it doesn't know what name I'm using. Username admin, privilege 15, and secret say Cisco. Right, so I created one local database here with the name admin is gonna get privilege 15, highest privileges, and secret is gonna ask Cisco, and we enabled the IP HTTP server. So if I go to my client machine, right, before I do that, let's open the Wireshark here. So right click here and click start capture. Yes, I want to router 1 FA00. Okay, so what I want to do is I want to see what reply from our DNS server. So if I go to the client machine now, and I want to put IP address of the server who's hosting the HTTP services. So 192.168.11.1, same as the gateway, is going to ask me for username and password, so admin, and the password is Cisco, we said, and click OK. Password didn't work, Cisco. Okay, something wrong with the password. I thought we put the Cisco, so let's just put, this is okay. Password Cisco. Let's repeat. Maybe there's a gap. No, password Cisco. Okay, so if I go to my Wireshark, and again I'm going to see some TCP, three-way handshake, DNS. So if you look at the DNS, a standard query here. So from 192.168.51.1, and let me just stop this. Okay, so here I got 192.168.51.1, and the query was domain name services query. The query was again for the Microsoft. There's nothing in there. Okay, so the main messages that we can see here is actually the TCP/IP conversation, which is three-way handshake. We see the synchronization message coming from the PC to the gateway, random port to port 80, synchronization 0, the window in is 8192, so the size of the window, then acknowledgement 1, which says I got you a sequence 0, send me number 1 first, next. This is my sequence. This message is coming from the server towards the client. This is my sequence 0. And then the client is sending to the server, which is like a third way handshake. It's got sequence 1, which is asking for it. And it says acknowledgement, your sequence 0 is being acknowledged. And then we say get, we are getting some main page, and it's been unauthorized. So if you look here, it's been unauthorized. So we can even look at this stream. So if we right click and say follow TCP stream, we can see what are the messages. It says here unauthorized. I don't know what. Okay, that was your explanation or demonstration on observing a DNS resolution.